Hello, this is Mr. Frank, and welcome to our Learning Target Simplifying Expressions. So let's get right into it. We've got to learn some vocabulary. This one's called terms. You know what they are. You might not know the name, but I know you know what they are. They are the parts of an expression that are being added or subtracted together. So in what you see here, 2x and 3x are called the terms, and those terms are being added together. So let's get a few examples to see how many terms are in each of the following. So we're on this first question right here. We've got an A, we've got a 2A, and we've got a 4. So let's go back to that definition and say the parts of an expression that are being added or subtracted together. So here's one part, here's another part, and here's another part. So if you said there were 3 terms, you'd be right. So let's go to the second one. Check out here, I got 5 different letters. Each one is going to be a term. So those are variables. It might look funny that we're adding variables and not numbers together, but that's okay. They're each their own term, and we've got 5 terms there. How about on this third one? How many terms do we have? Yeah, if you said 3, you were right. And how about this last one? We've got a 4 plus a 3 plus a 2 plus a k. Now remember, it's parts of the expression that are being added or subtracted together. So there are 4 parts here. So they're going to be 4 terms. So remember terms, and it's the parts of an expression that are being added or subtracted together. All right, let's learn another one, coefficients. In a term, it's the product of a number and the variable. That number is called the coefficient. So let's see what that looks like. All right, so here we've got 3xy plus 2x plus 4y minus 9. And there, that 3 there, that's one of our coefficients because it's the product of a number and a variable. It's what the number is. So there's another one. There's the 2 because we're multiplying a number by the variable x, so the number is the coefficient. And we've got one more. The 4 is multiplied by the 4y, so that's a coefficient as well. The 9 is not a coefficient because it's not in front of a variable. It's not being multiplied with a variable, so we don't consider it a coefficient. So let's take a look. Let's name our coefficients. All right, say it out to the screen right now. Which are the coefficients? All right, well, if you said 2 and 8, you see the color changing there? 2 and 8 are the coefficients because we're multiplying them. They're the product of a number and a variable, and those are the numbers. 3 is not a coefficient because we're not multiplying it by a variable. How about the second one? Yeah, if you said 1 and 9, those are the coefficients because we're multiplying them by each by a variable. So a coefficient in a term that is the product of a number and a variable, the number is called the coefficient. All right, one more. We got constants. So a term that has a number but no variable, that's called a constant term. So here's an example. We've got that 3xy plus 2x plus 4y minus 9. So we want to find the term that has a number but no variable. This one has a number and a couple of variables. This has a number and a variable, number, variable. This one has a number with no variable. That's our constant. So let's take a look. Name the constants. In the first one, is it the 2? Is it the x? Is it the 8? Is it the y? Is it the 3? Well, we're going to look for something that has a number but no variable. That's the 3. And how about in the second one? Which one's the constant? And if you said 7, you would be right. So I want you to, let's review constants. It's a term that has a number but no variable, right? Now I want you to, you'll answer this in Edpuzzle. We've got 3 definition questions. So answer that and come on back. All right, hopefully you did great on those questions. I'm sure you did. If not, maybe rewind a little bit and go through those 3 definitions again. So now we're going to get into combining like terms. All right, a little meaty here. Whoa, what's going on here? We got a lot of different pictures. We've got the Kardashian clan here. We got a guy with his dog taking a selfie. We got a picture from Frozen, another selfie, Kardashians, Frozen, another selfie. So we got a lot of different things going on. And do you notice that there's sort of a grouping or categories that we can make? Let's see, I think we can make some categories here. Let's take the selfie pictures and put them together. That's one category. We could take the Frozen pictures and put them together. Let's get Kim Kardashian out of there. She doesn't belong with Frozen. We'll put her with her family. So we put different groups together. And putting different groups together is something we do very naturally. So we could do it very naturally in math as well. And that's where we get to combining like terms. So let's give another example here. Using math, we've got 2x cubed plus 4x squared plus 3x squared plus 5x. To help you understand the different groupings, I'm going to substitute the variables for something for a second here. We're going to put in apples, oranges, and bananas. So instead of x cubed, I'm going to put in apples. Instead of x squared, let's split that orange and put those oranges in front of the x squareds. And we'll put the banana in for the x. Now, we're pretty familiar with this. Let's see what it looks like. I got 2 apples, I got 4 oranges, and then 3 more oranges, and I got 5 bananas. And just like we have the addition signs, the plus signs here, I'm going to put them here. Now, with the oranges, I don't need to say 4 oranges plus 3 oranges. I could combine those and put them together, and we have 7 oranges. So I can actually rewrite this as 2 apples plus 7 oranges plus 5 bananas. And that's the same as what we had up here. Notice what I did is I added the 4, the coefficient here, plus the 3, the coefficient here, that were both coefficients of the same fruit or the same variable. I added them up to get 7 oranges. And that's what combining like terms is. If you see the exact same variable, then you can add up or subtract, depending on what the sign is, the coefficients. So let's take a look. Like terms are terms that have identical variable parts. They're like terms, like this 2x and 3x. The variable is the exact same for both of them. So they're considered like terms. I like to think about it, they're both in the x family. And if they're both in the x family, we can put them together, and we get 5x. So 2x plus 3x, that would be 5x, because the x family likes to hang out together. So we put them all together, just like we did with the oranges. So terms have identical variable parts. Like terms have identical variable parts. So how many like terms are in the following expressions? So here, let's take a look here. Which do you think are the like terms? Well, this one's part of the A family. This one's still part of the A family. There's 2 of them. And those would be the like terms. There are 2 like terms. On the second one, there are no like terms. They're all different families. The A family, the B family, the C family, the D family, and the E family. So there are no like terms. On number 3, we've got 2 terms in the X family, so they're together, they're like terms. We would be able to combine them. And in the last one, we actually have 3 like terms. Constants are considered like terms. So you can always put constants together. Even though you don't see a variable, since they all have no variable, they're part of the same family, or they are like terms. So let's simplify each of these expressions. We'll do these together. I've got 4x minus 2x. So I'm going to use colors. They're part of the same family, so they're the same color. And what I would do is I would take the coefficient 4. I have minus 2, so if you want to change subtraction to addition, you can say plus negative 2. So 4 plus negative 2. That would give me 2, and I'd keep the x. This is part of the 2x family. It's part of the x family, I should say. So you get 2x. Let's take a look at this. I now have 3 terms that are part of the y family, and I can combine them. So 7 plus 2 minus 3 would give me 6, and I would keep the y there to say that it's part of the y family. All right, now we've got 10x minus 12x. They're part of the same family. They're part of the x family. I'm going to combine like terms, and I would get negative 2x. And here we're getting a little more complicated. I'm going to use colors to figure this out. I've got some x squareds. I got a 3x squared minus x squared. So I put those together. That's 2x squared. 3 minus 1 would get me 2. Then I have a negative 5 and a plus 6. I put those together and I have an x. So I simplify that to 2x squared plus x. All right, let's check out the colors we have. We got 2 y squareds in that family. A 2y squared plus a y squared gets me 3y squared. I got the y family. That gets me a negative y. And then I have a constant family, which I just keep as 2. Whew, there's a lot going on here, but check this out. I've got a 10 minus 7 minus 3. That's 0. On my x cubes, I got a plus x cubed minus x cubed. That's 0. And I got a plus 8 and a minus 8. That's 0. This whole thing equals 0. So that wasn't too hard. All right, on your own, I want you to do these 2, and you'll bring them back to class tomorrow. So do that in Edpuzzle. All right, welcome back. So please end with what you learned or were reminded of and questions that you have are. Hope you enjoyed the video. See you in school.